We're in the early stages of the age of AI. Each one of the previous ages dramatically changed human life, and AI will do that as well. Sundar Pichai, the CEO of Google, says that AI is more profound than electricity or fire. And he may well be right. But the age of AI is just beginning. And under the discontinuity, there's continuity. Notice how each of the ages builds on the previous ones. We are actually still in the age of agriculture, and we're still in the age of industry. In its early days, industry was largely driven by the needs of agriculture. And today, AI is largely driven by the needs of industry. Notice also how there is no age of information in this picture. IT is just the vanguard of AI. In the early days, computers were called electronic brains. And that's exactly what they are. We've just forgotten that. They just keep getting more powerful and cheaper, and we can do more with them. In each of these ages, what happened was that the cost of something plummeted. And as a result, its use massively increased. And that brought a lot of other changes in its wake. In the age of agriculture, it was the cost of food. In the age of industry, it was the cost of energy. And in the age of AI, it's the cost of intelligence. So how will this sea change play out, and how can you write it? Well, to manage AI and to make the most of it, you don't need to understand the gory details of how it works, but you do need to have a good conceptual model of what AI is and what it does. It's a little bit like driving a car. You don't need to understand how the engine works, but you do need to know how to use the steering wheel and the pedals. But the problem today is that most people don't even know where the pedals and steering wheel of AI are, let alone how to use them. So think of this talk as a driving lesson. I can show you where the controls are, and I can go over the rules of the road, but there's no substitute for driving the machine yourself. So let's start with what AI is and is not. So this is, the traditional Terminator slide that every AI talk has to have. So I'm going to honor that tradition. Now, there are a lot of misconceptions about AI. And honestly, the fault for those misconceptions is partly ours, the researchers, because we called it artificial intelligence. But the media haven't helped either. And I think partly because of that name, the single biggest misconception that people have about AI is that they confuse it with human intelligence, when in reality, the two are extremely different. In particular, AI, we often call this the homunculus fallacy, which is that you look at an AI system and you picture it as if there's a little man in there, pulling some levers and whatnot. That is emphatically not how it works. In particular, people often picture, this is what you see, journalists and even serious economists talking about all the time, is AI replacing humans on a one-to-one basis. An AI radiologist, an AI tax accountant. This is not how it's going to work. Each job is composed of multiple tasks, and it requires a multiplicity of skills. And AI is good for some of those, but not others. So what every worker has to do is figure out what are the parts of their job that the AI can do, and then you can do a lot more of it and do it better, and what are the parts that the AI can't do, which actually now have much greater value. Right? As any economist will tell you, when the cost of something goes down, the value of the complements goes up. And this is what AI is going to do to cognitive work. It's actually going to increase their value. So there's not going to be a jobs apocalypse. AI is a more advanced form of automation. Automation has not caused the jobs apocalypse in the past, and it's not going to cause one now. Even less is AI going to be the Terminator. AI doesn't want to take over from people because AI doesn't want things. AI doesn't have a will. AI doesn't have emotions. AI doesn't have ambition. AI doesn't have consciousness. Those are human things. And AI is something else. Now, on the other side of this, there are also a lot of misconceptions about what AI can do. A lot of people think, and usually the higher level in a company you go, the more you see this, they're often told that AI is really, for example, just applied statistics, so big deal. Well, actually, AI is not just applied statistics any more than engineering is just applied math, or any more than a house is just a pile of bricks. Now, statistics provides a lot of very good bricks for AI, but we still need architects, right? A pile of bricks does not turn itself into a house. Apropos of hype, another thing that AI is not is X, where X is whatever I happen to be selling at the moment. Whenever something is hot, I'm sure you've all noticed this, everybody tries to borrow the heat. So beware about what is being called AI and whether it really is or isn't. One other thing you see a lot of in the media these days is how AI is supposedly a cesspool of bias. AI is always discriminated against women and minorities and so on. But the fact is that to date, there has not been a single proven case of that happening. In fact, the people who seriously study these things will show you with a ton of evidence that AI-based decision-making is much less biased than the humankind. And if you use AI systematically, it can greatly improve fairness. So what is AI? Let's start with the technical definition because I think it's actually very helpful. AI is solving intractable problems using heuristics. Most problems in computer science can be solved efficiently, and that's what traditional computer science is all about. But there are problems that fundamentally cannot be solved efficiently. And then things get interesting. What happens then is that we have to resort to using heuristics to solve them. And heuristics are rules of thumb that when you use them, they work most of the time, but they don't always work. We sacrifice infallibility for efficiency. Humans are the masters of doing that. And AI is the art and science of getting machines to do the same. Now, of course, where does this come into play? It's often or largely in things like vision, language control, and so on. And when you hear about the successes of AI in the media, it's often in areas like that. But the general idea here is really the following, right? If you're familiar with the observe, orient, decide, act loop, right? A very time-honored concept. What AI really does is automate and accelerate that. And so now your OODA loop is faster, it's on a larger scale, and you win. That's how you win in war, where the concept originated, and in business. One important consequence of AI solving problems by computer using heuristics is that AI is never solved. There's always the next best thing that you can do in AI, and often it's, these improvements are quite dramatic. So AI is always a moving target. If you plan your strategy around the AI that exists today, by the time you execute it, it will be outdated. So you always have to be planning your AI with what's coming out of the labs in mind. And I will return to this later. Here's another, I think, important way to look at AI. It's as a force multiplier. If you have a company with 1,000 employees, having AI is a little bit like having a company with 1 million employees instead. But the cost is not 1 million times more. The main cost is actually going to be the cost of paying your existing workers more because they are now more valuable. The cost of actually buying the AI systems is typically a rounding error. And paradoxically, again, counter to what people usually think, AI is actually a very labor-intensive activity. But the point of that is that the value that you get out of that activity can be tremendous. Like the return on investment of having people do AI can be spectacular, and that is the #1 reason why it's taken off. So what are the steering wheel and the pedals of an AI system? AI systems keep getting more complex, and the variety keeps ever growing. So how do you find your way in this jungle? Actually, it's not that hard if you realize that every AI system, or pretty much every AI system, is composed of the same three things. And you got to have, if you have a handle on what those are and what to do with them, you're actually in very good shape, and you're not lost in the jungle anymore. So the first of those things is representation. Representation is the choice of language that your AI thinks in, if you will. So humans, our language are things like English, Chinese, Swahili, and so on. And in traditional computer science, it's programming languages like Python and Java and C++ and so on. In AI, it's things like deep networks and knowledge bases and graphical models. Now, representation is actually an extremely difficult problem. Human languages are extraordinarily flexible, and AI languages are extraordinarily rigid. And that's actually a big part of the problem. Now, what you probably, and it's a research problem that will continue for a long time. What you probably want to do today is use an existing one, at least to start with. But it is a very deep scientific problem that there's a lot of room to improve on. Now, the next component is evaluation. Evaluation is the metric that the AI uses to decide how well it's doing. All of the things that the AI is doing is to optimize this measure that you set up. And evaluation is the steering wheel of the AI system. What you use for an evaluation function has major consequences. The evaluation function is often very simple, like shockingly simple. It can be something as low level as squared error for regression, or something as high level as return on investment. In social media, notoriously, the evaluation function is engagement. And the fact that the AI is just trying to maximize engagement has a lot of consequences. Notice that the AI is extremely powerful, right? There's these masses of data, there's these tons of computing, and they are all going into maximizing this one number. So choose it carefully. This is actually the kind of thing that you do not want to delegate. And then finally, there's optimization. Optimization is the process by which the AI system optimizes the chosen metric. And this is the engine of the system, right? You can make it go faster. There's a lot of engineering, creativity that can go into this, but it's not necessarily something you need to worry a lot about from a business point of view. So for example, in deep networks, the optimization is gradient descent. You tweak the parameters of the network to make it fit the data better. Which brings us to the central role of machine learning in today's AI. For the first 50 years, we tried to do AI the same way other problems are solved, which is you write a program to do the thing, the vision or the language processing or the planning and so on. But that didn't work because it's just too hard. The reason AI is where it is today is that we have a different paradigm now. The paradigm is that we learn it from data. So in traditional programming, the data and an algorithm go into the computer, and the algorithm processes the data, and out comes the desired result. Machine learning turns this around. The data goes into the computer, and the desired output goes into the computer. And what the computer produces is the algorithm that transforms the data into the desired output. So for example, you can send in lung X-rays and diagnosis of lung cancer, and then the machine learns to diagnose lung cancer. Right? So when this works, it's extremely powerful. And as you get more and more data, it becomes more and more powerful. And that's why we can do the things we can with AI today. So how does this work? There are 5 main ways. The most popular one these days is deep learning. Deep learning consists of very roughly emulating what the brain does. You build a large network with a lot of neurons, and then it learns by adjusting the strengths of the connections between those neurons. It's best for perceptual tasks like vision and speech and so on. Symbolic AI is automating the scientific method. The machine formulates hypotheses, tests them on data, refines the hypothesis, or in some cases discards them, and repeats. This is best for higher level things like reasoning and planning and problem solving and so on. Bayesian inference puts a probability distribution on the state of the world and then continually updates that distribution as new data comes in. It's very useful when the data is very noisy, and it also combines very nicely with classic decision theory. Evolutionary computation emulates natural selection, except that instead of evolving plants and animals, it evolves programs. And it can, in principle, evolve a whole brain rather than just tweaking its weights like deep learning does. And reasoning by analogy is actually what all of us do every day. When you're confronted with a new problem, you retrieve from memory previous similar problems that you've solved before, and you port the solution over to the new problem. When you don't have a lot of data, this is often the only method that works. To learn more about this, as was already mentioned, I recommend this book by this guy, Pedro Domingos. It's, it is a bestseller, and I wrote it for you. So let's suppose that you have the basics of AI under your belt and you decide to do an AI project. The first thing to figure out is whether the application that you have in mind is potentially a good application for AI or not. So here are a few rules of thumb for that. AI is good for narrow, well-defined tasks with lots of data to learn from. So for example, it's great for things like credit scoring or direct marketing, and those were indeed some of the first applications of AI. It's also good for tasks where the cost, this is often not appreciated, it's often very good for tasks where the cost of errors is low. Because AI is never perfect and often very far from that. So things like spam filtering and ad targeting AI is fantastic for. Things like a self-driving car, maybe not quite, at least not at this stage. But here are other interesting things, and less obvious ones, or even less obvious ones. AI is very good for tasks that we don't know how to program. These could be tasks that actually we as humans know how to do very well. We just don't know how to explain to a computer how to do them. Think of walking, right? We all know how to walk, but nobody knows how to program a robot to walk. But the robot can learn to walk from observing people walking. Or a car can learn, or a self-driving car can learn to drive by watching video of people driving. It can also be tasks that we don't know how to program simply just because we have no idea how to do them at all. Like, for example, curing cancer. We don't know how to cure cancer, but with enough genomic and other data and with sufficiently smart algorithms, there are a lot of biomedical researchers that think that's how we're going to get there. And here's another one. There can actually be tasks that humans can do, and maybe we even can think how to program them, but the problem is that using humans for the task is just not cost effective. So it doesn't scale. Think of Amazon's recommender system, right? Amazon's recommender system is like having your own friendly local shopkeeper. One for everybody, except at a fraction of the cost. Right? And now you can do it for everybody. And this is very powerful. Reportedly, a third of Amazon's business comes from its recommender system, and 3/4 of Netflix's. So this is, recommender systems are probably the most important application of AI today, and it's because of this. It's also good to remember what AI is not good for. If the application that you have in mind requires one of these, you're probably skating on thin ice. The first one is common sense reasoning. Common sense is the million little pieces of knowledge that we all have and take for granted, like if it rains, people get wet unless they're indoors. AI has no common sense. And this is a huge Achilles heel. Another one is integrating very disparate streams of information continuously in real time and deciding, also in real time what to pay attention to. Humans are amazing at this. You could even say that that's what consciousness is all about. And AI is not there yet. AI is also not very good for things that we humans actually think are very low level and we take for granted, but are actually extremely sophisticated. Like, things like, hand-eye coordination. tasks that you think are totally trivial, but the thing is that the reason they are trivial is that evolution spent 500 million years, optimizing us for them. So we take them for granted, but when you get to trying to do them with AI, they're very hard. And the upshot of all this is that AI is often good for the opposite of what you think it will be. The history of AI is the history of surprises like this. So for example, we thought that blue-collar work would be easier to automate than white-collar work. It turns out to be the reverse. This has a lot of consequences, as you can imagine. People think that processing emotions is hard for machines and cognition is easy, and it's actually exactly the opposite. People think that machines will never create, but we already have machines today that compose music and do paintings that are indistinguishable from the ones that humans make. Wine tasting. Figuring out the vintage of a wine by tasting it sounds like a very sophisticated human thing, but it's trivial for machine learning to do. Making the beds and doing the dishes, those are damn hard. I kid you not. Selecting players for a baseball team, well, we've been doing that for over 20 years, as Michael Lewis well documented. Construction work, we're nowhere close to that, right? If you can automate a construction worker, that would be great, but it's not on the horizon. More generally, we tend to think that expert knowledge is, doing expert work is hard for AI and doing everyday work is easy, but it's the opposite. Precisely for the reason that I just mentioned, is that the everyday stuff evolution spent 500 million years optimizing us for. Anything that requires a college degree, almost by definition, is something that we are not naturally good at, and therefore is a good target for AI. So at the end of the day, don't trust your intuition. Really, the only way to know if an AI will work for an application or not, other than these rough guidelines, is to just try it and see. And you may be surprised one way or the other. But there is, however, one, I think, overarching theme to what AI can do for you, a guiding principle, if you will. And it's this. Think of all the knowledge in the world as a pyramid. At the top of that pyramid is a small amount of highly certain, very deep knowledge, like mathematics. And physics, which is less certain, there's more of it, but still not a huge amount, but still, this is some of the strongest knowledge we have. And then there's biology, of which there's even more knowledge, and it's weaker. And then there's chemistry, there's psychology, there's economics, there's sociology, more and more knowledge, less and less certain. But even when you add up all of that knowledge, it's still only a fraction of the knowledge you need to successfully run a company. Most of the knowledge you need is actually extremely specific things. This process, this component, this relationship, this customer's preferences. But there's a huge amount of it. And that's what machine learning is good for. Because all of that knowledge, or a lot of it, is in the data. And the machine learning can extract it. And we're just getting started doing that. When we're done mining all that knowledge that exists in the data, it will dwarf the knowledge that was painstakingly accumulated over the centuries by scientists and engineers and other specialists. So, let's say you've picked an application that you're going to use AI for, and now the next question is, which technique should you use for that problem? Right? There's a wide variety to choose from. Here's an important thing to keep in mind. The jazziest technique is not necessarily the best one for your problem. Try nearest neighbor before you try deep learning. It'll probably get you, it's not as sexy, but it'll probably get you most of the way, and it'll be a lot easier. These days, the media and startup pitches are full of what we in the field call dancing bear demonstrations. Look at what my system can do. Isn't it amazingly intelligent? Now, be careful. Because we human beings, when we look at what an AI system is doing, have an amazing tendency to project human intelligence into it, or the human way of doing things. And that's not necessarily how it works. Here's an example that I think is very illuminating. So some colleagues of mine at the University of Washington, they trained a deep network to distinguish dogs from wolves. And of course, we're the Huskies, so here they are. And, it's pretty good. See, like it, predicts most of these things correctly. Occasionally, it gets one wrong, like this one here. It's actually predicted to be a wolf, but it's actually a husky. But, it's doing a good job, right? So this network understands, what a wolf is and what a dog looks like, right? Actually, no. This network knows nothing about dogs and wolves, right? Can you tell what's going on here? What's going on here is that the wolves are in a snow background and the dogs aren't. So this network has just learned to look for large white patches. That's what it knows how to do. And this happens in machine learning all the time. Right? This is just one example of many. Now you could say, well, that's okay. I mean, as long as the wolves appear in a snow background and the dogs don't, this is doing a good job. And in fact, a lot of things that evolution produced in animals work like that. On the other hand, if you ever see a wolf in your garden on a beautiful spring morning, this could, be a dangerous, thing to do, right? So, beware. Remember that for the time being, this is why it's important to not just trust the results, but understand how they are being obtained, right? So, you have to understand what the AI is doing, and the AI for the foreseeable future will need adult supervision. The big risk with AI is not that the AIs get too smart, is that they're not smart enough. That's what dangerous is. AI is, it's not Terminator, it's AI that's not smart enough. So here's a few more things to bear in mind when doing an AI project. The importance of data cannot be overstated. AI is built on data. Collecting the data, cleaning it, integrating it, maintaining it, making it easy to use are a central function of any AI-based organization. Data is the new soil. And if the soil is barren or toxic, then no good AI can grow on it. So this is something that really needs a lot of attention. No hammers. To the data scientist with a hammer, every problem looks like a nail. Something that you see in a lot of organizations is that they hired some data scientists that belong to some school of AI, often for random reasons, and then they hire more like themselves. And then they pound screws into walls with hammers, and they dig in the garden with hammers. Be very aware of this, because that's how you make very costly mistakes. Mistakes of millions and billions of dollars have been made because of this. It's like your AI staff should cover the whole waterfront, either because they're individually well-rounded or because they complement each other, or both. And every AI project should involve lively discussion among people from these different schools, followed by learning from the data, followed by more discussion. And the number one question that you want to ask your data scientists is, what assumptions does your model make? Again, you don't need to understand the details of how the model is learned, but you have to be able to understand, question, and revise the assumptions that the model makes. And if when you ask that question, they don't have a good answer for you, then red lights should be flashing. Arguably, the subprime meltdown of 2008 was caused by models that were learned with assumptions that people didn't realize they were making. So at the time, subprime CDOs were a new product, and so the data that they were learned from was all data from when the market was going up. So the models, without them realizing it, actually encoded the assumption that the market always goes up. And the data scientists doing this, like they were, to maybe unfairly cartoonify them, were mostly like mathematicians and physicists with no great interest in finance. So, they were learning their models, they were happy. without really understanding what the models were saying. And their bosses didn't understand very well what they were doing either, but the math was very fancy, and they were making a lot of money, so why mess with it, right? Well, you saw what happened. Right? So be very careful. Now, here's another thing to bear in mind, which is the difference between a quick solution and the best solution. The first solution to your problem will typically be based on an off-the-shelf algorithm that you tweak, and that is, good enough often to get, pretty good results. But the best solution is going to be a one-of-a-kind learning system that embodies a lot of the knowledge about the problem, that it complements what you can get from the data. And algorithms like this are the crown jewels of every AI-based company. Think of Google's search ranking algorithm or Amazon's demand forecasting algorithm. And that's the point where you want to eventually get to. So let's suppose that you have a good AI organization in place. The next question is, what is the best division of labor between the AI and the humans? So here's a very simple Venn diagram. And the part of this diagram that people are always thinking about is this intersection. It's the things that AI can do that humans can also do. And this is what makes you worry about job losses and so on. But you have to notice that by far the greater part of this is the stuff that AI can do that humans can't. That part is harder to see because it's not what you're doing today, but it's where the biggest opportunities are. So look for them. Now, of course, as I said before, AI is a moving target. So what AI can do tomorrow will be greater than what it can do today, and that's unfortunately not the case for humans because we don't change as fast. So over time, this intersection does get bigger. But again, notice that this part gets much bigger. And actually, even this is only still a very incomplete picture because the real essence of what goes on here is this. Is this things that humans and AI together can do that neither of them could do alone. It's not man versus machine. It's man with machine versus man without. AI will not replace radiologists, but radiologists who use AI will replace those who don't. So the real question is not how do you divide labor between humans and AI, it's how does each worker make the most of AI in their job. So here's what typically happens, right? When an organization starts using AI. Step one, the experts ridicule the notion. It's like, how could a mere computer program possibly be a match for all my years of learning and experience? And when the decision of whether to use AI or not is controlled by the experts, often it isn't. This is happening less and less, but it still does. And of course, what happens is that sooner or later somebody says, well, let's try AI. And then often what happens is that the AI is spectacularly successful. It does better than anybody imagined possible. Like the Netflix prize is a great example. Their data scientists decided that you couldn't improve it anymore. And they said, like, well, let's do a public competition, but nobody's going to succeed. And they had a target for improvement, and the people blew past that in months. And then it wound up being like, it's still improving based on the things that were discovered then. But then, this is not the end of the story. Because at some point, the data scientists run out of tricks. But the demand for improved performance is still there. And then, surprise, surprise, the data scientists start talking again to those experts that they thought they no longer knew. That they thought they no longer needed, and maybe no longer knew either. Because it turns out that actually a lot of the knowledge that those experts have is actually what you need to get the most leverage out of the AI. So this is actually the process that you want to aim for, is to have an organization where the knowledge that you have and the data that you have work together well. Which brings us to a very important point, which is the following. AI in an organization is not just something that the data scientists do or that you hire a few people with PhDs to do. Using AI is part of everybody's job. Imagine if in an organization, the only people that used spreadsheets and word processors were the people in the IT department. Because, it's information technology, so why should anybody else deal with it, right? Well, big mistake. Everybody, your goal should be to have AI at everybody's fingertips, from the CEO down to the lay customer. And then, of course, there's a very wide range of expertise, and the kind and level of AI that you want for these different people is very different. But you do have to think about every one of them. You can't just think about the data scientists over there. At one end, there's the lay person, the user, right? Someone who doesn't know anything at all about AI. And the tech companies have really tried hard to make AI invisible to the end user, which I think is a mistake. Everybody, the evaluation function that gets used, for example, in the recommender systems that use, should be under your control. You should be able to interact with an AI more than just, indirectly giving it data to learn from. You should be able to more explicitly tell it what you want it to do. And we know how to do that today. Then there are the professional users of AI who use AI every day but don't create AI. For example, I'm told that at Google these days, every time that someone has a problem, the first question that they ask is, where can I find the data to build a model for this problem? And that's the general idea. And then there are, of course, the data scientists and the people who do machine learning. But even here, there's a large spectrum of how you want to, of how much they do, like how much they create versus how much they use, existing tools and so on. And of course, the people with machine learning PhDs are very expensive these days, and they're hard to hire. But you can, entice them with the impact that they can have and how interesting the problems are in your domain. And they'll probably be expensive, but again, the return on the investment will probably be very, very high. So how do you make the most of those data scientists, right? They're a very scarce and very important resource. Here's an issue that I've noticed over and over in organizations that I interact with, which is this question of whether your AI group should be, whether it should be a central AI group or groups at the different units. The way things usually play out is that initially different divisions or different parts of the organization, be they product-based or region-based or function-based, they create their own data science groups on an as-needed basis. The problem with this is that there's a lot of duplication. And there's a lot of, there's knowledge in the organization that already exists that somebody else needs, but they don't know it's there. I mean, more than once I've had the experience of somebody asking me, how do you do X? And then what I do is I point them to the people at their company that are currently doing X. So at some point, what usually happens is that a central AI group is created. And this solves the duplication problem, but now there's a different problem, which is that almost always the business units wind up feeling that the AI group is not responsive to their needs and vice versa. So what is the solution to this problem? The solution to this problem, I think, is to have both. You need a central AI group as a central switchboard for knowledge about AI, to work on the problems that are common to everybody, to be a link to the wider AI community so that they can import the novelties and also make the needs of the company felt in the community. But at the same time, you also need data scientists who are very close to the action, who are in the firing line. And you need motion between the two. Somebody may start out on a very specific problem because some division needs it, but then they realize that the problem is more general, and they move to the central group to work on it for everybody. Or somebody can start out working on a general problem, this also happens very often, and then they get more and more focused on a particular application, and then they move to that group to actually implement it and see how it goes and improve it and so on. So what should happen is that your organization and the AI that it uses, and the structure of things, should evolve with each other. So far we've talked about AI inside the organization, but what about AI outside it? That is also extremely important. Some of you have probably seen this diagram. It's a landscape of AI with different areas and different companies within each one. This was started about 10 years ago by Matt Turk and Siobhan Zillis, and with every new edition, it doubles in size and becomes more incomplete. So how do you make sense of this vast ecosystem? Well, to be honest, it does pay to get to know every part of this because you might need it. And another really good idea is to come to conferences like this one. So in the time that I have, let me just focus on one issue, which is how do you deal with the tech giants? Right? Knowledge is power, and knowledge equals data plus machine learning, so whoever has the most data and the best machine learning wins. In particular, there's nothing more important than knowing your customers, and the tech companies often know a lot about your customers that you don't. And data has network effects. So if you have more data, you can learn from that and build a better product, as a result of which you get more customers, and then you have even more data, and so on. And a slight data advantage can quickly become an insurmountable data chasm. And even if you have a lot of very valuable knowledge in your domain that the tech giants don't have, you could still wind up commoditized with the big rewards going to them. And you don't want that to happen. So how do you avoid that? Well, there's a few things that you can do. The first one is, your customers are a source of data. And that can be a decisive advantage. And you have a closer relationship with your customers than the tech giants do. So you want to turn that into a data advantage. The key word here is trust. Your customers should be happy to share data with you because they're confident that that will be to their advantage. Whereas with the tech companies, they may not be so sure. Another one is to form alliances. It is to get data from others. You can buy data, but that's actually not the most important thing. The most important thing is to make a coalition with your complementors, the upstream, downstream players, to build up a critical mass of data to the point where you can compete with the tech giants in your domain. And you can also collaborate with them. In this, as in many other things, it's often this fine balance of where do you collaborate and where do you cooperate, and you have to think about that very carefully. And the key word here is leverage. What AI does is leverage data, but knowledge is the lever that you use to leverage the data. Right? So the more knowledge you put in, the more leverage you get out of the data. Right? This is actually knowledge that if you don't use your knowledge in your AI, it's knowledge that you don't use in your AI is like money you don't invest. It doesn't grow, and as a result, it becomes a smaller and smaller piece of the pie. So I mentioned earlier that AI is a moving target, so you have to plan for what's coming out of the labs, not just what's already widely used in industry. So let me just mention a few of the more important things. Here's one. That is, this already, there are already many companies that do this, but most still don't. At most companies, AI is done as a series of one-shot projects. You gather the data, you model it, you do a bunch of tests, and then you deploy it, and it lasts a while, and then, when it's obsolete, you do another one. This is actually not how AI should work. AI should be always on, continually learning, continually adapting like a living organism. That's what you want to aim for. Here's another one. Almost all of the AI that's used in industry today is what is called supervised learning. It's like the diagram that I showed earlier. For each input, you have to give it the desired output. The AI needs a teacher, if you will. But there's a limit to how much of data like that you have. Most of the data comes without supervision, but you can still learn a lot from it. It's like children. Most of the learning that humans do as children is not supervised. It's not what their parents or teachers tell them. They learn by observing and playing in the world and so on. And there's been a lot of progress in AI on this, and we can do a lot of that as well. And then you probably want to combine it with the supervised learning, but leveraging the data that you have without supervision is actually key to success. Here's another one, a little bit further out. AI today is typically used to optimize some process, right? To reduce the cost of something or convince customers to buy something. But what actually needs to happen is that this also has to go the other way. The processes also have to be optimized for AI. The essence of intelligence is predicting things in order to control them. But most things are fundamentally unpredictable. However, you can often control them well enough to make them predictable enough that you can control them. And really, you could say that this loop is the essence of intelligence. Humans do it, animals do it, and AIs should do it as well. Here's another one, further out, but actually this last one is in some ways already a huge problem, except that most people and most companies are not aware of it. But this, in the long run, might be the most important one of all of this. And this is the following. Almost all uses of AI today work in the following mode. I build a model of something, and then that something continues to behave as the model describes forever. And we know that this is not true for a number of reasons, but the most fundamental one is that whenever you model people and take actions based on it, people's behavior changes as a result. Right? So in a way, there's like this game that is being played between the modeler and the modeled. And when people's behavior changes, that renders your model obsolete. Okay? And now you can always be playing catch up with this, or you can try to get ahead of it. And another aspect of this is that you are not the only one building and deploying models. Everybody else is too. So what we actually have in the world today that is very new is this vast ecosystem of people and AIs modeling each other and acting accordingly. The stock market and ad networks were early examples of this, but these things are basically everywhere now. So there's this vast game that is being played, and in fact, there's an area of science that deals with this, game theory. So the future of AI is the marriage of machine learning and game theory, and we're already starting to see some of that, but I think we're going to see a lot more in the future. So to conclude, what does a company that makes full use of AI look like? Let me end with 3 metaphors, each of which I think captures a different aspect. AI is the nervous system of your organization. But it's not like a human brain. A human brain is too centralized to be a good metaphor for an AI-powered organization. Maybe a better metaphor is an octopus that has a different brain in each of its arms, in addition to the central one, and then they all communicate. Now, I know, octopuses don't have the most positive image, but they're actually some of the most intelligent creatures on Earth. So think distributed AI, right? These units are all partly independent, but they're also working together for a common goal. Here's another aspect. Running an AI-powered company is a little bit like flying an airplane, except that what you're controlling is not flaps or jet engines. It's a vast flow of data and optimizations and decisions and customer interactions and so on. In an AI-powered company, most of the day-to-day work is done by machines, and what people do is steer those machines. And finally, with AI, the whole is more than the sum of the parts. The problem with organizations, and the bigger they are, the worse it gets, is that the intelligence of the organization is less than the sum of the intelligences of the people who work in it. This is a tragedy, and it's not the people's fault. It's because of the straitjacket that the organization's structure and processes and lines of communication put them in. And AI changes this. AI removes the bottlenecks. It dissolves the rigidities. It augments the powers of the people, and now they finally can realize their full potential. Agriculture and industry both led to entire new forms of organization and civilization, and so will AI. And it's happening a lot faster. So today is an exciting time to be alive. Thank you.